Hello, yeah, welcome back. All right, so still on set and determinant, and we're looking at the basic operation in set. Okay, so the very first operation we'll start with is addition and subtraction. Okay, now to add and subtract set is just very easy. Okay, you add the set based on their position, the position, okay, of the element of the matrix. Please pardon me, I'm using set. Okay, to add and subtract matrix, we add based on the position of the element. Okay, we add at the same position. For example, we are looking at two matrices. Okay, we have matrix A and matrix B. Okay, having their position as follows. So if I want to add, if I'm adding these two matrices, I'm going to have a new matrix, okay, because the addition of matrix will produce a new matrix, okay. So now, of course, let's say the new matrix is going to be C. So each position, of course, from this formula you see here, the I represent the rows while the J represent the columns. So that means the new matrix now, each element in the new matrix C, okay, is going to be the sum of the position, the element of matrix A plus the element of matrix B, okay, at the same position of the row and the same position of the column. So which simply means that, okay, if I'm looking for C 1 that is the sum, okay, so it's going to be the addition of A11 column 1, all right, column 1 row 1 column 1, okay, of the A matrix, then plus B11, right, row 1 column 1. So now for this to actually make sense, in case it doesn't make sense, let's look at a typical example. All right, now let's look at a situation where we'll have two matrices. I'm going to use 2 by 2 matrix, okay. So let's say have matrix A to be equal to 2 1 3. Okay, then of course 4. Then it's added to we'll have another matrix, matrix B. Okay, so let's say 3 1 2 5. So now if I'm being asked to evaluate, excuse me, so if I'm being asked to evaluate the sum of these two matrices, okay, let's say I'm being asked to evaluate A plus B. Okay, so it will be very easy. All I just need to do is just to add, okay, at the position. So it's going to be 2, because I'm going to add 2, okay. 2 is the element at row 1 column 1 of A matrix. Then I'm going to add it to the sum. So my new matrix now is going to be equal to 2 plus 3, okay. Then I'll have, at this point I'm having 1 plus 1. At this point I'm having 3 plus 2. And at this point I'm having 4 plus 5. Okay, so it's just as simple as that. As simple as that. So my new matrix now is going to be equal to 5 2 5 then 9. Okay, so it's as simple as that. For example, also if you're being asked to do A minus B, okay, so the same thing, but this time around we'll subtract. So this is going to be equal to 2 minus 3, 2 minus 3, 1 minus 1, 1, 3 minus 2, then of course 4 minus 5. Alright, so now of course my product, my sum now is going to be equal to, or rather my difference is now going to be equal to this minus 1. This will be 0. This is 1, and this is minus 1. So as simple as that. That's addition and subtraction of matrix. So any order of matrix or dimension of matrices is still going to apply the same process or procedure. Okay. So we are done with this. So let's look at the multiplication. And okay, multiplication of matrix is much more difficult, okay, than the addition. So looking at multiplication. So in multiplication of matrix, I'm looking at two types of multiplication. Let's look at just a scalar multiplication. Okay, scalar, where I multiply a matrix by just a single number. Then let's look at vector multiplication, where I multiply a matrix by another matrix. Okay, for example, let's start with the simple multiplication, where you multiply a matrix by just a scalar. Okay, by scalar product. For example, let's say you got matrix A to be equal to 2, 1, 3, 2, 2, 1, 4, 5, 2. Okay, and here you want to do 2A. Simple. Okay, so all you need to do, you're multiplying 2. This is just you multiply the entire matrix by 2. So the entire element of the matrix, you are multiplying it by 2. So it's just gonna be as simple as doing 2 times 2, 2 times 1, 2 times 3. Okay, 2 times 2 here also. All right, 2 times 2. 2 times 1. 2 times 4. 2 times 5. And of course, 2 times 2. All right. So it's gonna give me 4. This is gonna be 2. This is 6. There's a 4. 4 to 8. Okay. Here I'm having 10. Then of course 4 again. Okay, so that's that for multiplying matrix by just a single number. But the difficulties is much more complex when you're multiplying a matrix by another matrix. Okay, but by the time you know how to do it, it will no longer be difficult. So let's look at vector multiplication, where you have a matrix. You're multiplying a matrix by another matrix. Okay, now in that case, let's say you have a matrix, 2 matrix. Okay, the same, let's say A11. Let me just use 2 by 2. Okay, A12, A13, A21, A22, A23, A33, A31, please pardon me. This is A31. A31, A32, and A33 is one matrix. Then I'm now multiplying it, okay? With another matrix, this time B. Okay, so it's B times B11, B12, B13, okay, B21, B22, okay, here I have B23, B31, B32, and B33. Okay, so now anytime you are being asked to multiply matrix, okay, two matrices. Now this time around, the product of these two matrices is done when I multiply row against column. Unlike in addition, where I'll add row to row, I add, okay, the same position, but here we multiply row against column. So invariably now, my multiplication is gonna go by, let's say, okay, CIG. My product is going to be C, okay? The product of these two matrices is C. So it's going to be gotten when I do, okay, A JR, then times B, then IJ. This is just illustration. Then once I do that, now remember, okay, when I'm multiplying, I don't just have one element, okay, in a row, because I'll go row against column, okay. Let's do it this way. Let me row against column. So it's gonna be the sum of all the multiplication I do, okay, with the row against the column. So that means the first row will go through, will multiply the first row multiply both the first column, second column, third column. So it's going to be a multiplication of the row starting from row 1, okay, starting from the point where R is equal to 1, okay, to the point where I now have R, okay, being equal to K, and that is going to be, I'm multiplying the row against column. So now this will actually make sense. I will illustrate this formula, okay? I'll illustrate it using an example. Let's just look at simple 2 by 2 matrix. Let's look at a situation where you have matrix A to be equal to 2, 3, 1, 1. Then multiply by another matrix, okay? Let's say I have 1, 5, 2, 1. Okay, so now you have to multiply these two matrices, A times B. Now look at how it's going to go. The same way we actually expand, okay, in algebra, using one expression in a bracket to multiply everything in another bracket. So that's exactly how this one will go. The entire first row will multiply first column, second column. Are you okay? Then I will now start to go with the second row. We will still multiply first row, first column. So now look at how it goes. So I'll start. Remember, and of course, if I multiply at the same position. Now this is going to be 2. That's going to be 2 times 1. Then the second element of the, remember, it's always row against column, okay? 2 times 1. Please pardon me. 2 times 1. 2 times 1. Okay? Then, of course, 3 times 2. Now, if that is going to be a problem for you to know, I would rather suggest, if you are not used to it, okay, you can arrange it. Arrange it in such a way that you know exactly what you're doing. Okay? This is a method I actually do because sometimes students find it very difficult. So I'm going to arrange a first row against first column. Okay? Now, the same first row, 2, 3. Then against second column. So first row has finished its job. Then now go second row. Second row against first column. Then the same second row against second column. So now it is just a cross. So multiplying this now is going to be, okay, based on position. So first row to first column, second row to second column. Right? The same way it goes this way. That is how you cross it. And of course, you're going to add the two products that you got. Okay, so now let's do that. So now I have my matrix now, which is going to be equal to, in this case, this is going to be 2 times 1, then plus 3 times 2. Okay, remember, use plus to connect the products. Then the same thing happens here. Here I have, 2 times 5, then plus 3 times 1. I'm done with that. Okay, so let's go to this. So I'm having 1 times 1, then plus 1 times 2. This happens also that I'm going to have 1 times 5, then plus 1 times 1. Yes, I'm done. So now my resulting matrix now is going to be equal to 2 plus 6, okay? And that should be 8. Here, 10 plus 3, this should be 13. Here, 1 plus 2, this should be 3. Here, 5 plus 1, and this should be 6. As simple as that. Okay, so let's look at a more complex example. Let's look at 3 by 3 matrix, okay? The multiplication of 3 by 3 matrix. Let's say I have A to be equal to 2, 1, 1, 3, 2, 1, 1, 1, 2. Then I have P to be equal to 3, 2, 2, 1, 2, 1, 1, 1, 1. Okay. So A times P. Okay, so with what I did now, you know exactly what I'm going to do. First row against first column, second column. That's how it goes. Okay, so I can still arrange that. 2 1 1 against 3 1 1. Okay, so but I'm not necessarily to go through all this. You only use this method if you're not gotten used to, okay, the multiplication. So you can just go straight to the multiplication. So now I'm gonna start. That's gonna be, first of all, that's gonna do 2 times 3, okay, then 1 times plus 1 times 1, okay, then of course plus 1 times 1. Okay, so the same row, I'll go again for second column. So I still have 2 times 2, okay, then 1 times 2 plus 1 times 2, then plus 1 times 1 times 1. Okay, so let me shoot this out. I'll have space. All right, so let's go to this, the same row here against the third column. So it goes this way: 2 times 2 plus 1 times 1 plus 1 times 1. Okay, so second column now we start work. Here we go. 3 times 3, then plus 2 times 1, then plus 1 times 1 times 1. Okay, second column, I got second row versus second column. Okay, so here we go. 3 times 2 plus 2 times 2, then of course plus 1 times 1. All right, and the same thing goes with this. Here we have 3 times 2 plus 2 times 1, then plus 1 times 1, which of course is 1, right? Then I'm done with second row. Then third row will start. Let's start with third row. That's gonna be 1 times 3. 1 times 3 plus 1 times 1, then plus 2 times 1. Okay, so here we go. 1 times 2 plus 1 times 2 again, then 2 times 1. Okay, so finally 1 times 2, 1 times 1, which of course is 1, then 2 times 1, which is 2. So bringing everything together now, so I have my answer. This is 6 plus 1, 7 plus 1. That's gonna be 8. 4 plus 2. plus 1, that's 7. 4 plus 1, 5 plus 1, that is 6. Okay, so let's do this. 9 plus 2, 11. Then plus 1, that's 12. 6 plus 4, 10. Plus 1, 11. 6 plus 2, 8 plus 1, that's 9. 3 plus 1, 4, plus 2, 5. 2 plus 2, 4, plus 2, 6. 2 plus 1, 3, plus 2, 5. So that is our answer, as simple as that. So I hope that is well understood. Okay. Now we are done with the operations of matrix. Okay. So we are now going to enter into determinants. Okay. Determinants. Now, what's a determinant of a matrix? Okay, of course, determinant is for we evaluate the determinant of matrix. Okay, so anytime you are being asked to evaluate determinant, the determinant is meant for, it's an operation on a matrix. Now, the determinant of a matrix is simply, in a simple term, okay, is the scalar value of a matrix, or the magnitude of a matrix, anyhow you want to look at it. Okay, remember, every matrix is made up of arrays of numbers. All right, made up of arrays of numbers. So what is the actual, if I should actually combine all those arrays of numbers, what is that single number, okay, or single value that represent the entire array of number? That is what we, okay, that is what we refer to as the determinant. So invariably now, okay, if I have matrix A, which of course, let's say I'm using A11, A12, okay, then A21, A22, okay, these are 2 by 2 matrices. This is the matrix, okay, that have arrays of elements, rows and columns. So if I'm being asked to evaluate the determinant, okay, if I'm being asked to find the determinant of A, invariably I'm asked to find the magnitude of this array. Okay, so the determinant of A is always expressed as the magnitude. Okay, so we use these 2 straight lines to represent determinant. So the symbol for determinant, so yeah, the symbol for determinant is different from the symbol of matrix. Why? Because for matrix, okay, we use chain bracket, a long chain bracket, but for determinant we use 2 straight line. Okay, so if you see me using this 2 straight line to express matrix A11, A12, A21, and A22, invariably, okay, I'm referring to what determinant. So you should know the symbol, right? The difference between the symbol of a matrix and the symbol of a determinant. So the question is, how do we actually evaluate determinant? It's just very simple. Okay, so let me take this. So let's look at this. We want to evaluate, and be asked to evaluate the determinant of A. So the determinant of the matrix A, okay, is simple. I'm going to subtract the product of the diagonal matrix. What do I mean by diagonal matrix? Measure diagonal, okay, let's say the left, will I call that right diagonal, okay? Then another diagonal. So these two diagonals. So I'm going to multiply them and subtract them. But first of all, I will start with the major diagonal. Okay, that's A11 times A22. Excuse me. Then minus, okay, the minor diagonal. Okay, let me call that minor diagonal. So which of course, please, this is A23, please pardon me. Okay, so the minor diagonal, so that's gonna be A11 times, so whatever you have becomes the determinant of that matrix. Okay, so let's look at this. Let's just look at example. So let's say we have 2, 1, 3, 1. Okay, so if you are being asked to evaluate the determinant of A, so all you're just gonna do is start with the major diagonal. The product of the major diagonal is 2 times 1. Then minus the product of the minor diagonal, which of course is 3 times 1. Okay, so this is gonna be 2 times 1 is 2. Then 3 times 1 is 3. Okay, so of course 2 minus 3 is going to be minus 1. So as simple as that. So the of evaluating the determinant of 2 by 2 matrix is just very simple. Just very simple. For example, let's say you're being asked to evaluate 3, 2, 1, 5. Okay, now by doing this, you know very well that this symbol shows that this is the determinant of this matrix. Okay, so invariably that's gonna be major diagonal, their product, that's 3 times 5 minus the product of the minor diagonal. Okay, 2 times 1. So this is gonna be 15 minus 2, and of course 15 minus 2, that gives me 13. Okay, so anytime we evaluate determinant, we always have a single value. So the entire arrays of the numbers, which of course is a matrix, will give me just one single value, and that is why it is called determinant. Okay, now as I said, the determinant of 2 by 2 matrix is just simple. It's as simple as what I just did here. But what happens with 3 by 3? Okay, is it possible for me to use diagonal that will cover the entire element of the matrix? Let's find out. Okay, let's look at determinant of 3 by 3 matrix. Okay, so let me still use call it matrix A, which of course is A11, A12, A13, A21, A22, A23. Okay, then A31, A32, and of course A33. Okay, so I'm having this as my matrix. Then I'm asking myself if I should actually use the same method, okay, I used to evaluate the determinant of 2 by 2 matrix. Will it work, okay, in this case? Now it will definitely not work. Why? Even if I should go by diagonal, by major diagonal, okay, let's say I go by major diagonal, then I go this way also. You discover that there's some element of the matrix is actually left out. Okay, they are left out, they are not included. So how do I actually resolve the determinant of 3 by 3 matrix? Okay, for me to be able to resolve the determinant of 3 by 3 matrix, I will split the 3 by 3 matrix into 3 corresponding 2 by 2 matrix. 3 corresponding. Okay, each one of them will have okay, I'm gonna take out 3 2 by 2 matrices out of them with a scalar product. Now let me tell you what I mean. So let's start. So the determinant of this matrix is gonna be equal to, I'm gonna take out 2 by 2 matrix. So that's the first row, the element of the first row is gonna be their scalar product. Scalar product, that's going to be the product that multiply the 2 by 2 matrix. Okay, so let's see how that happens. So I'm going to start with the very first element there, which is A11. They are now multiplied by each corresponding 2 by 2 matrix. How will I get the corresponding 2 by 2 matrix of this first element here? It is just very easy. All I just need to do is to cross the row of that element I want to get the matrix. Okay, the row of 2 by 2, and also cross the column. Once I do that, any other element matrix that's left becomes the corresponding 2 by 2 matrix of that element. Okay, so that is it. That's going to be A22, A23, and of course, so let's do that. So that's going to be A11 multiplied by the determinant of A22. All right, A23, A32, and A33. Okay, so I'm done with this. Now remember, the next is always minus. Okay, when we do plus, the next is minus for the next element. Okay, just like when we are doing a 2 by 2 matrix, when we multiply the major diagonal, the next is minus the minor diagonal. So in this case, for this now, since the first is plus, all right, the second is going to be minus. Okay, so now I'm having minus 1A12, then multiply by each corresponding matrix, 2 by 2 matrix. So I cross each column, I also cross each row. Then what I have left is what I'm going to use. Okay, so I'm having A21, A223. So that's exactly what I'm going to use. So A21, the determinant of A21. Okay, A23, A31, then A33. Then the next, now since I've used plus, now then for the next element, since I've used minus, the next element now will not be plus. So it start with plus, minus, plus. It will always start with plus, all right? Okay, so then plus, the next element is A13. Okay, let's do the same thing to this. Cross, and of course, you can always do this in a rough, okay? So in a rough, so that you get your corresponding 2 by 2 matrix. So of course, what I have, oh, I made a very big mistake. This is what I'm supposed to cross. Okay, so what I have left is A21, A22, A31, then A32. As simple as that. And we are done. Okay, so now let's look at example. Let's look at example. Okay, for example, you are being asked to evaluate the determinant of the matrix 2, 1, 3, 3, 2, 0, 1, 1, 3. Okay, so you'll be asked to evaluate the determinant. Okay, so the question is, so without even be asked, in this case you will only be asked to evaluate. Okay, so you don't need to be told that what you're actually evaluating is determinant. From the symbol, you know very well that this is actually what you're doing here is actually the determinant of this matrix. Okay, so let's go there. Solution. So I'll start with the very first element, equal to 2. What's the corresponding matrix? You know how that is. That's going to be 2, 0, 2, 0, 1, 3. Okay, then minus 1. Of course, the corresponding matrix, cross this, I have 3, 0. Okay, 1, 3. Plus the next element. Cross this, my corresponding matrix 2 by 2 determinant is 3, 2, 1, 1. So it's not easy for us to evaluate this now. To evaluate the 2 by 2 matrix, then multiply by the scalar value. Okay, this is going to be 2 times. You know how we do? We multiply the major diagonals minus the minor diagonals. That's going to be 2 times 3. That's 6. 6, 1 times 0 is 0. I'm done with this. Then minus 1, open bracket. 3 times 3 is 9. Minus 1 times 0 is 0. Okay, here we go. 3, bracket open. 3 times 1 is 3. 1 times 2 is 2. Okay, so here comes my answer. This 2 times 6 minus 0 is 6. 2 times 6 is 12. Okay, of course, 9 minus 0 is 9. Minus 1 times 9 will still give me minus 9. Okay, this is 1. 3 times 1 is 3. So here comes my answer. So 12 minus 9, and that should give me 3. Yep, that's then of course 3 plus 3, that's 6. That is my answer. That is my answer. Okay, so it's just very simple. Very simple. Very simple. Okay, so now, of course, you can actually set some question for yourself to practice this, but we are going to something else. We are going to look at a very important application of determinant. Okay, the application of determinant. Application of determinant of a matrix. Okay. Now, one of the very important application of determinant is found in the solution of linear algebraic equations, or what you know as simultaneous linear equation. Okay, simultaneous linear equation, an equation of the form a1x plus b1y equal to c1, which of course you call it equation 1, right? Then you have another equation, simultaneous linear equation. Of course, you must have actually worked on this before. A2x, that's for my equation 2, plus b2y, then equal to c2. So now, of course, this I can use determinant to solve this, okay, which is not which is quite different from the normal method that you could actually use to solve this equation. Okay, the method of elimination or substitution, but determinant can actually solve this in a using a faster approach and of course much easier approach. Okay, so let's see how that works. For me to actually solve this particular equation with determinants using determinant method, I'm going to apply a rule, okay, that actually help us to do this. That rule is a rule, okay, known as Cramer's rule. So Cramer's rule actually help us to find the value of x. Of course, for us to be able to solving this simultaneous equation is the same as finding the value of x and y. Of course, you know it's simultaneous equation, right? So what does the rule state? The rule state that if I want to get the value of x, simple, I need two determinants. All right, two corresponding determinants for x. The first determinant of x is going to be determinant that I actually generate from the coefficient, okay, of other variable except x. What do I mean by the coefficient of other variable? I have, apart from the coefficient of x, which is a1 and a2, okay, other coefficient I have here is of course b1, b2, and I have the constant c1, c2. So this will give me 2 by 2 determinant, right? But in the case of me looking for x, okay, I'm gonna go by, I'll start with c1. I'll use my first column is gonna be c1, c2, okay. Then of course the second column will be b1, b2. I know why I have to go by column. Why? Because the arrangement of Cramer's rule, the arrangement of the determinant, okay, when we are using Cramer's rule matters a lot, because if you don't arrange it well, if b1, b2 comes first, then definitely my answer will be wrong. So please take note, if you are getting your x, that means the very first variable, whatever it is, okay, your numerator, well, of course, there's going to be numerator and denominator. Your numerator determinant will start with the constant value, okay, as the first column. Then, of course, the second column now becomes the coefficient of the other variables in ascending order. But here I only have just one variable, which is y, and the coefficient of y, okay, in the two equation is b1, b2. Then I now divide it, okay, by the coefficient of all the variables, including x, in ascending order, okay. That is going to be starting with, of course, a1, a2. That's the coefficient of all the variables, okay, in ascending order, a1, a2, okay, b1, b2. This is how we actually find x. Then for me to find y, don't worry, I'm gonna illustrate this, okay, in case you don't understand it. The same rule is applicable. My numerator is gonna be a determinant of 2 by 2 matrix, but this time around, okay, I'm going to use the constant value. Now will not start, the constant value c1, c2 will now comes as the second column. Then the other coefficient, all right, which of course is the coefficient of x, right? The coefficient of x now is what now comes as the very first column. As I said, arrangement of this is really very important. So that is why I say you should always start with your constant value. Either place it with, okay, place it accordingly. For x, you place it in the first column. Then for y, place it in the second column, right? Then for, if this equation is of course is equation of 3 variables, for z, you first place it at the third column, then you now arrange others accordingly. Okay, don't worry, we'll look at example in case you don't understand this. So now my denominator for all the variable will still remain the same, okay? The coefficient of all the variable in ascending order, that is a1, a2, b1, all right, then b2. Please pardon me. Okay, so let's just illustrate this. Let's look at a situation where you are being asked to use Cramer's rule, okay, to solve, let's say, x plus y is equal to 2, then x minus 2y is equal to 3. These two equations, equation 1 and equation 2. All right, so of course, let me start with getting my value of x. To get my value of x, you know what I'm going to do, okay? The numerator, I'm going to divide, I'm going to, okay, get my very first determinant, okay? So remember, I have to start with the constant value at the right-hand side. So that's going to be 2, 3 as my first column. Then, of course, the coefficient of y becomes my second column. And the coefficient of y is, of course, 1 in equation 1, then minus 2 in equation 2. Then divided by the coefficient of the, okay, the determinant of the coefficient of the entire variables in ascending order. That's the coefficient of x here is 1, coefficient of y is 1, the coefficient of x here is 1, and the coefficient of y is minus 2. Okay, so let's do this. Of course, you know how we do determinant. That's going to be 2 times minus 2. That's going to be minus 4. Then minus our minor diagonal 3 times 1, that is 3, divided by the same thing happens here, 2 times minus 1, that's going to be minus 2. Then 1 times 1, that's 1. Okay, so my answer now for x is going to be equal to minus 7 divided by minus 3, which of course is 7 all over 3. As simple as that. Okay, so now to get y still gonna be, okay, the same procedure, but please take note that you always have to start with the constant value. Okay, so for y, the constant value, or the constant value of the equations will be your second column. Don't forget. Okay, so what's my constant value? That's 2, 3. So it will be your second column before you now go to, okay, the coefficient, and this time around the coefficient of x. So that's 1, 1. Okay, in this case, divided by the same denominator. All right, the coefficient of the variables, 1, 1, 1 minus 2, 1, 1, okay, 1 minus 2. Okay, so let's evaluate this. Of course, this is going to be 3 times 1. This is going to be 3 minus 2. And this is going to be minus 2. Okay, then minus 1. So when you do this, it's going to be 1 all over minus 3. Okay, so as simple as that. This is Cramer's rule. Okay, so it can solve, with this rule, it can solve any algebraic system of algebraic equation of any number of variables. So what we just did, we just applied Cramer's rule for algebraic equation with just 2 variables. Okay, let's see how that works with 3 variables. Let's see how that works with 3 variables. Okay, now for 3 variable, we are looking at something of this nature: a1x plus b1y plus c1z. Okay, so the 3 variable is x, y, z, so equal to d1. I call this equation 1. Then equation 2, I'm having a2x plus b2y then plus C2Z equal to D2. I call this equation 2. Then I have A3X, excuse me, A3X plus, okay, B3Y, then plus C3Z equal to D3. So this is not going to be my equation 3. Okay, applying Cramer's rule. Okay, it's not going to be different from what we did previously. Okay, but it's just that we're having more variables now to deal with. Okay, so Cramer's rule for me to find x. Remember, this time around, now since this is an equation in 3 variables, then my determinant will definitely be 3 by 3 determinant. Okay, so I'm gonna have, remember, if I want to get the determinant for x, which of course will be at the numerator, right? Okay, so now remember I have to start with the constant value d1, d2, d3. Okay, so now that is gonna form my very first column. Okay, now for the other 2 columns, I'm going to take the coefficient of the other variables, of course, in ascending order accordingly. Okay, starting with y before z. So I'm gonna start. So the second column is gonna be b1, b2, all right, then b3. The next there's gonna be c1, c2, c3. So this is my numerator, then divided by the denominator, which of course you know what that's going to be. Okay, so the denominator is going to be the coefficient of all the variables, okay, arranged accordingly in ascending order. Of course, there's going to be a1, okay, b1, c1, a2, b2, c2, a3, b3, c3. We are done. Okay. For y, remember what I told you? Okay. For y, then the constant, okay, value forms the second column. So you have to write that down first. Write it down first, okay? That's going to be D1, D2. So that you know exactly where to place the others. D1, D2, D3. Okay? So the others now, which of course is the coefficient of x and z, okay, is now being written accordingly. So I'll start with the coefficient of x being the first column, a1, a2, and a3. Okay, so I have that of z, okay, which of course is c1, c2, c3, then divided by, okay, the same determinant, a1, b1, c1, a2, b2, c2, a3, b3, okay, then c3. Okay, so the last but not the least, now let's look at how we get our z. So let me actually clear my screen. So to get my z, you know exactly what we're going to do now to get my z. Okay, so this time around, okay, the determinant now, the constant value actually will be the last column. That's d1, D1, D2, D3. Okay, so now others now, which of course is the coefficient of A and of course the coefficient of X and Y. Okay, so that's gonna be A1, A2, okay, A3, then B1, B2, B3. Okay, then divided by A1, B1, C1, A2, B2, C2, A3, B3, C3. Okay, so that is how we evaluate that equation. So I would have loved to give you an example, right? But I will do that in the next video. Okay, so just go through this. As we return, we are going to look at example. Okay, see you in the next video. Thank you very much.